Alright everybody, welcome back to Physics with Arif. Today we're going to do Unit 2.05. Mr. Arif forgot to tell me to make this and Unit 2.02 the same. So I'm doing this separate, but he's letting me do it a little shorter Alright, so first is uniform acceleration. A uniform acceleration has a straight line, but it's quite rare in real life. This means that the acceleration is constant. It is gaining speed at a steady rate. As you can see, the red line on the graph is straight. Well, I mean it's diagonal, but it means it's straight. So this means that it's gaining velocity, aka speed, at a steady rate. For example, a rock is falling without air resistance. This means that it is gaining speed at a steady rate due to gravity. Non-uniform acceleration. Non-uniform acceleration means that it has different speeds. It is not straight. As you can see, the graph is zigzag up and down all around. And this basically means that it is not gaining speed at a steady rate. It is losing speed and is gaining speed randomly. An example would be a car speeding up and then he sees some traffic, so he slows down a bit, maybe even coming to a full stop, and then he speeds back up again. This is non-uniform acceleration. You can see in the previous slide I said that non-uniform acceleration is more apparent in real life. This is because non-uniform everyday things don't usually speed up and accelerate at a normal pace. They usually, they do something like this, zigzag up and down all around. Like a car, like I just said, or a bike. A guy might be cycling, he sees a hill, so he slows down a bit. Next, some examples. This is a graph of a rock falling without any air resistance. You see that the red line is straight. This means that it keeps accelerating and keeps accelerating until, I presume, it stops because it hit the ground. Or, I don't know, he stopped paying attention, I guess. Next, this is a graph of a rock falling with air resistance. As you can see that the graph is kind of curved and it's plateaued. This means that with air resistance, it keeps falling, and then eventually the air resistance is equal to its acceleration. This is called terminal velocity. We have talked about this before, and basically it's just it stops speeding up. And basically, that's it. That's the end of this slide. It's only 3 minutes, but I hope Mr. Arif will forgive me. I just want marks.